So this is the Trinago V bridge, maybe Trinago 5 bridge. I don't speak Italian, so I'm a little lost. And what it is it's a multiple segment bridge, and you can see these bridge segments. Oh, let's go back to pink. That's not the pink we wanted. Okay. So we have these multiple bridge segments, and they're roughly speaking the same length, right? And so if you have a bridge segment that's kind of roughly speaking the same length, and they might vibrate at close to the same frequency, right? Now they're also coupled, right? So when you build a bridge, just as a very, very, very basic view, you might have a column that sits like that, or a pier that sits like that. And you have your bridge deck that sits on it, and you have your bridge deck, and you have your bridge deck. And then on top of this, you come and lay some asphalt, right? And now what you've created here is a system, let's call that AB, that is just loosely coupled, right? So you have a system that's naturally wanting to vibrate that is loosely coupled at this connection. So it's not perfectly coupled. So you're going to get vibrations that move through the structure, but they're not going to be super, they're not going to be a strong coupling. So what does that look like if you were to actually put a sensor on this bridge and measure it? So we have several structures that are close to the same, but not the same. And then they are loosely coupled, and it gets quite hard, actually, to figure out what's going on. And so make that larger. This is the dynamics of that bridge, like so monitored over a long period of time. And what you see here is in this amount of the PSD, the power spectral density, you have your first modes, right? And each section of the bridge has its own first mode. And that first mode is relatively close to the first mode of other sections, but it's not the same. And so you have more of a distribution. And then here you have more or less the second modes. And could you say, well, no, that's the second and third mode? Possibly, but really what I think you're picking up here is you might be measuring one section of the bridge, and you're picking up the second mode of another section of the bridge that's kind of transmitting in. Does that make sense? So again, the moral of this story is just that these structures are very complicated. If you think of an airplane structure and how you have bolts and kind of rubber and tar that hold different pieces together. And so when you're picking up vibrations on a wing, you might actually be picking up a mode associated with the vibrating of the aircraft on a landing gear. That's kind of, that energy is being transmitted up. So just something to think about